What if we are not the first? Not the first civilization. Not the first intelligence to look at the stars and wonder. Not the first to build cities, shape stone, split atoms, and change the climate of an entire planet. What if we are simply the most recent? It sounds like science fiction, the kind of idea reserved for late-night documentaries and speculative novels. But in 2018, two serious scientists asked this question in a peer-reviewed paper. Not did a previous civilization exist, but something far more unsettling. If one had, would we even know? Let's start with a number. 4.5 billion. That's how old the Earth is. 4.5 billion years of fire, collision, ice, ocean, extinction, rebirth. Now compare that to another number, 300. That's how long our industrial civilization has existed. 3 centuries since we began burning fossil fuels at scale. 3 centuries since steam engines, smokestacks, and carbon began reshaping the atmosphere. 300 years out of 4.5 billion. If Earth's entire history were compressed into a single 24-hour day, complex life would appear around 9 p.m. Dinosaurs would rule the late evening. They would vanish at 11:40 p.m. Modern humans would step onto the stage at 11:59 and 56 seconds. And industrial civilization? It would flicker into existence in the final fraction of a second before midnight. Everything we've ever built, every skyscraper, satellite, cathedral, supercomputer, fits inside a sliver of time too thin to see. So, here is the uncomfortable question. In 4.5 billion years, is it reasonable to assume that intelligence emerged only once? Complex life has existed for more than 500 million years. Mammals have been here for over 200 million. Dinosaurs ruled for 165 million years, far longer than humans have existed as a species. We went from stone tools to smartphones in about 12,000 years. Dinosaurs had 165 million. It's not a mystical question, it's a mathematical one. In 2018, astrophysicist Adam Frank and climate scientist Gavin Schmidt decided it was time to ask it seriously. They called their idea the Silurian Hypothesis, a playful reference to an old science fiction episode about ancient reptilian beings that once ruled Earth. But their paper wasn't about reptile people. It was about geology. Specifically, what does an industrial civilization actually leave behind? Imagine humanity disappears tomorrow. No explosion, no asteroid, no apocalypse. We simply vanish. What happens next? Within weeks, power grids fail. Within months, vegetation begins pushing through pavement. Within decades, wood rots and steel rusts, glass fractures, concrete crumbles. Within a few centuries, most buildings collapse. Within a few thousand years, cities are buried under sediment and soil. Within 100,000 years, erosion reshapes the land. Rivers change course. Coastlines shift. Glaciers advance and retreat. Within 1 million years, tectonic forces have begun recycling entire regions of crust. And after 10 million years, nothing recognizable remains. No Eiffel Tower, no pyramids, no highways, no statues. Only a thin chemical fingerprint trapped in stone. That is the key. Civilizations do not last in the rock as monuments. They last as chemistry. We produce hundreds of millions of tons of plastic every year. We alter nitrogen and phosphorus cycles. We detonate nuclear weapons that leave radioactive isotopes embedded in soil and ice. Most importantly, we burn fossil fuels, releasing carbon that was locked underground for hundreds of millions of years. That carbon has a signature, a distinct isotopic ratio, and it is changing the planet. Now imagine an intelligent species evolving 50 million years from now. They drill into sedimentary rock. They analyze carbon isotopes. They find a sharp, sudden spike, a burst of light carbon injected into the atmosphere in geological terms almost instantly. As they see ocean acidification in the layers, temperature spikes, species extinction, would they conclude, Ah, yes, a natural methane release. Or would they whisper, something industrial happened here? That is the core of the Silurian hypothesis. Not that there was a prior civilization, but that if there had been, the evidence might look exactly like a natural climate event. Because Earth is not a museum. It is a machine. It melts, crushes, subducts, erodes, dissolves. Ocean crust is recycled every 200 million years. Continental shelves sink beneath rising seas. Mountains rise and grind back into dust. Less than a fraction of a percent of any species that ever lived becomes fossilized. Time is not passive. Time destroys. Oh, so Frankenschmidt asked, are there anomalies in Earth's deep past that resemble the fingerprint of industrial activity? The answer is yes. About 56 million years ago, something extraordinary happened. Geologists call it the Paleocene-Eocene Thermal Maximum, the PETM. In what appears to have been a geologically brief interval, perhaps as short as several thousand years, an enormous amount of carbon flooded into Earth's atmosphere. Global temperatures surged between 5 and 8 degrees Celsius. The Arctic became subtropical. Crocodile relatives swam near the poles. Deep oceans lost oxygen. Marine ecosystems collapsed. The planet reorganized itself. And embedded in rock layers from that time is a sharp negative carbon isotope excursion, a chemical signal consistent with massive injections of biologically derived carbon. Sound familiar? Today, we are injecting biologically derived carbon, fossil fuels, into the atmosphere at an unprecedented rate. The isotope signature is strikingly similar. Now, mainstream geology explains the PETM through volcanic activity, methane hydrate release, orbital forcing, and feedback loops. These mechanisms make sense. They are supported by evidence. But here is the haunting part. If a fossil fuel-burning civilization had existed 56 million years ago and had collapsed quickly, the chemical fingerprint might be indistinguishable from what we call the PETM. Let that sink in. Not because the PETM was caused by a civilization. There is no evidence for that, but because our tools cannot easily tell the difference. The needle is made of the same material as the hay, and the deeper you go in time, the more incomplete the record becomes. Most of Earth's surface from before the last few million years has been recycled. Vast stretches of ancient crust are gone forever, subducted, melted, transformed. We are trying to reconstruct deep history from fragments. Core samples pulled from ocean floors, exposed cliffs, rare undisturbed sequences. It's like trying to understand an entire novel when 99% of its pages have been burned. We assume we know the story because the remaining fragments seem coherent, but we have to admit something uncomfortable. Well, we don't actually know how many chapters are missing. The Silurian hypothesis does not claim that a previous civilization existed. It does something more powerful. It exposes the limits of our certainty. Because absence of evidence is only meaningful when evidence would have survived. And on a planet that grinds continents into magma, survival of evidence is the exception, not the rule. There is another detail that makes this question even sharper. Where do civilizations tend to form? Near coasts, along rivers, at trade crossroads. During the last ice age, sea levels were more than 100 meters lower than today. Vast continental shelves were dry land. Landscapes that are now beneath the ocean once hosted ecosystems, rivers, and potentially human settlements. When the ice melted, those lands drowned. Slowly in some places, catastrophically in others. Entire coastlines vanished, and marine archaeology has barely begun exploring those submerged worlds. If a civilization had flourished along Ice Age coastlines, Its remains would now lie beneath hundreds of feet of water and thousands of years of sediment, hidden in plain sight. This is not proof of anything. It is a thought experiment, a humbling one, because it forces us to confront a possibility. We may not be able to prove we are the first. We simply assume it, and assumptions in science are dangerous, especially when the planet itself is designed to erase. But the story does not end 56 million years ago. There is another anomaly, not in deep time, not in the age of dinosaurs, but close enough that we can almost touch it. About 12,800 years ago, at the end of the last ice age, something happened. Temperatures that had been rising suddenly crashed. Megafauna vanished across continents. A sophisticated stone tool culture disappeared. And a layer in the soil contains microscopic materials that should not be there. This time, the scar is not buried 56 million years deep. It is just beneath our feet. And whatever happened then, happened to humans. That is where we go next. 12,800 years ago, the world was thawing. For thousands of years, massive ice sheets had gripped the northern hemisphere. Walls of frozen water, miles thick, pressed down on continents. But slowly, steadily, the climate warmed. Glaciers retreated. Rivers swelled. Grasslands expanded. It must have felt like the beginning of a new age. And in North America, mammoths still roamed the plains. Saber-toothed cats stalked the forests. Giant ground sloths lumbered through woodlands. Herds moved across open tundra beneath vast skies. And humans were there. Not primitive caricatures with crude instincts, but skilled hunters. Precise, adaptive, intelligent. One culture in particular stands out. We call them the Clovis people. They left behind exquisitely crafted stone spear points, fluted, symmetrical, engineered with a level of precision that still impresses archaeologists today. Their tools spread across much of North America in what appears to have been a rapid expansion. They were thriving. And then, in what may have been a human lifetime, everything changed. The warming stopped. Temperatures plunged. In Greenland ice cores, the data suggests that average temperatures may have dropped by as much as 10 to 15 degrees Celsius, not over millennia, but over decades. The planet snapped back into near glacial conditions. Scientists call this period the Younger Dryas, named after a small Arctic flower whose pollen suddenly reappeared in European sediments, a quiet botanical signal that winter had returned. For over 1,200 years, the cold persisted. And during that same window of time, something else happened. The megafauna vanished. In North America alone, dozens of large animal genera disappeared in geological terms almost instantly. Mammoths, mastodons, giant sloths, American lions, saber-toothed cats, short-faced bears, camels, horses, gone. Climate change can drive extinction. Human overhunting can drive extinction. But the speed and scale of this collapse are still debated. Because it wasn't just animals. The Clovis culture vanished too. Their distinctive spear points disappear from the archaeological record at precisely the same boundary. What replaced them was different, simpler, as if a cultural thread had been cut. For decades, the dominant explanation for the Younger Dryas cooling was oceanographic. As the ice sheets melted, enormous glacial lakes formed in North America. One of them, Lake Agassiz, was vast beyond imagination. When it drained catastrophically into the North Atlantic, it may have flooded the ocean with fresh water. The Atlantic circulation system, the great conveyor belt that transports warm water northward, depends on salinity and density. Disrupt it with enough fresh water, and it can weaken or shut down. Less warm water reaching the north. Colder temperatures across Europe and beyond. It is a solid theory. It explains much. But in 2007, a group of scientists proposed something far more dramatic. They suggested that the trigger came not from melting ice, but from the sky. At dozens of sites across North America, and later across Europe and parts of the Middle East, researchers identified a thin layer in the soil dating to approximately 12,800 years ago. Inside that layer were things that should not be there. Nanodiamonds, microscopic diamonds formed under extreme heat and pressure. Magnetic microspherules, tiny metallic droplets created when material melts and resolidifies in midair. Elevated iridium, an element rare in Earth's crust but common in extraterrestrial objects. Shocked quartz, grains fractured in patterns typically associated with cosmic impacts or nuclear detonations. And soot, evidence of widespread burning. The team proposed that a fragmented comet entered Earth's atmosphere, exploding in multiple airbursts over the northern ice sheets. Not a single crater-forming impact, but a cascade of explosions. Imagine thousands of Tunguska-scale events. The 1908 Siberian explosion that flattened over 2,000 square kilometers of forest, multiplied many times over. If detonations occurred over the Laurentide ice sheet, the shock and heat could have destabilized vast volumes of ice. Meltwater would surge into the oceans. Atmospheric dust and soot would block sunlight. Fire and cold. A chain reaction. The Younger Dryas impact hypothesis was born. The reaction from the scientific community was immediate and fierce. Critics argued that there was no definitive crater of the right age, that some of the microspherules could form through terrestrial processes, that the nanodiamond evidence was inconsistent. Supporters refined their methods, they expanded sampling, they identified similar markers at over 50 locations. In 2018, researchers reported the discovery of a large impact crater beneath the ice of Greenland, the Hiawatha structure. Its precise dating remains debated, but its existence proved something important. Large impacts in this time frame are possible. Then came additional findings: crater-like depressions and high-temperature melt signatures in North America, consistent with atmospheric airbursts around the same boundary. The debate continues. Mainstream consensus still favors ocean circulation disruption as the primary cause of the cooling. But the possibility of a cosmic trigger has not disappeared. And here is why this matters for our story. If a catastrophic cosmic event struck the Northern Hemisphere 12,800 years ago, triggering fires, climate collapse, megafaunal extinction, what was the state of humanity at that moment? The conventional answer is simple. Small bands of hunter-gatherers, mobile, resourceful, but not urban, not agricultural, not architectural, no cities to destroy, no monuments to topple. But that narrative has cracks. Because just a few centuries after the Younger Dryas ended, something appears in southeastern Turkey that should not exist. High on a ridge in the region of modern-day Anatolia stands a site called Göbekli Tepe. Its oldest layers date to roughly 11,600 years ago, almost exactly when the Younger Dryas cold period ended. And what stands there defies the timeline. Massive T-shaped limestone pillars, some nearly 5 meters tall, weighing up to 20 tons, arranged in circular enclosures, carved with reliefs of foxes, lions, boars, snakes, vultures, scorpions, and abstract symbols. The pillars are not random. They are positioned with geometric precision. Recent analysis suggests that multiple enclosures were planned as a unified design, connected through specific angular relationships. This was not an accidental accumulation of stones. It was architecture, monumental architecture. But here is the part that unsettles archaeologists. Göbekli Tepe predates agriculture. There is no evidence of domesticated crops in its earliest phase. No pottery, no metal tools, no written language. According to the traditional model, permanent temples arise after farming, after food surpluses allow specialization and organized religion. Göbekli Tepe reverses that order. The temple came first, which means either hunter-gatherers were far more socially and organizationally sophisticated than we assumed, or they inherited knowledge from somewhere else. Klaus Schmidt, the archaeologist who led excavations at the site, suggested that building the temple may have driven the invention of agriculture, that gathering large labor forces required stable food sources. And interestingly, some of the earliest domesticated wheat strains have been identified not far from the site. But there is another interpretation, one that remains controversial. What if Göbekli Tepe was not the beginning of civilization, but a response to catastrophe? The timing is tight. The Younger Dryas ends. Within generations, monumental construction begins. On one pillar, known as the Vulture Stone, carved symbols have been interpreted by some researchers as possible astronomical references. A sky event, a date encoded in animal constellations corresponding to around 10,950 BCE, near the onset of the Younger Dryas. This interpretation is debated. But imagine for a moment, if a devastating cosmic event had occurred, if climate collapse had followed, if knowledge had been lost, populations scattered, coastlines drowned, would the survivors build? Would they carve memory into stone? Would they mark the sky? We must be careful. Speculation is not evidence. Göbekli Tepe can be explained within the framework of complex hunter-gatherer societies. Human beings are capable of extraordinary coordination without agriculture. The archaeological data supports gradual cultural evolution. But Göbekli Tepe proves something undeniable. Our ancestors 12,000 years ago were not simple. They were capable of abstract symbolism, large-scale cooperation, and monumental construction long before we thought possible. And if they could do that, what else were they capable of? Now combine three facts. First, sea levels at the end of the Ice Age rose by more than 120 meters. Second, most human settlements tend to cluster along coastlines. Third, those coastlines are now underwater. If any advanced Ice Age coastal society existed, maritime, navigational, perhaps even proto-urban, its remains would lie beneath continental shelves we have barely explored. Not erased entirely, submerged, buried under sediment and silence. The Younger Dryas may have been a climate anomaly. It may have been an ocean circulation glitch, or it may have involved a cosmic trigger. But whatever its cause, it marked a violent transition in human prehistory. Megafauna vanished. Cultures shifted. The world reset. And immediately after that reset, monumental stone architecture appears. That is not proof of a lost civilization, but it is a pattern that begins with a scar in deep time, the PETM, and moves forward to a scar closer to us. Fire from the sky, cold from the ocean, stone rising from the earth. If the first segment asked whether we could detect a civilization millions of years ago, this segment asks something closer to home. What if we are not looking far enough back? What if the anomaly is not 56 million years old, but 12,800? And what if the echoes of that moment still surround us? Because the next anomaly does not lie in Turkey. It sits in the desert, carved from bedrock, staring at the rising sun. And some geologists believe it has been watching far longer than history admits. It sits in the desert, massive, silent, unblinking, a lion's body carved from bedrock, a human face staring directly at the rising sun, the great Sphinx of Giza. According to conventional Egyptology, it was carved around 2500 BCE during the reign of Pharaoh Khafra. It fits neatly into the Old Kingdom timeline. It belongs beside the pyramids. Case closed. Except there's a problem, a geological problem. In the 1990s, a geologist examined the Sphinx enclosure and noticed something strange. The limestone walls surrounding the monument show deep vertical weathering patterns, rounded channels that resemble prolonged rainfall erosion. Not wind, not sand abrasion, water. The Giza Plateau today is arid, and it has been largely desert for thousands of years. Wind-driven sand produces horizontal striations, sharp edges, angular erosion, but the enclosure walls around the Sphinx display undulating vertical grooves, consistent, some argue, with sustained rainfall. When did Egypt last experience heavy rainfall? During the African humid period, roughly between 12,000 and 5,000 BCE, when the Sahara was green, dotted with lakes and rivers. If the Sphinx enclosure required centuries of significant rainfall to produce that weathering, then the monument, or at least its core, might be older than the conventional 2500 BCE date, possibly much older. Some researchers have suggested dates as early as 7000 BCE. Others push it back further, to around 10,000 BCE, near the end of the last ice age. And mainstream Egyptologists reject this conclusion. They argue that alternative erosion mechanisms, groundwater, salt crystallization, sand burial cycles, can account for the patterns. They point to stylistic similarities between the Sphinx's face and statues of Khafra. The debate remains unresolved, but the possibility lingers. If the Sphinx were significantly older than we think, who built it? There is no known Egyptian civilization 10,000 years ago capable of carving monumental bedrock sculptures, unless something existed before what we call the beginning. There is another detail. The Sphinx faces due east. On the spring equinox, it looks directly at the rising sun. So because of axial precession, Earth's slow wobble over a 26,000-year cycle, the constellation rising on the eastern horizon at dawn on the equinox changes over time. Around 2500 BCE, that constellation was Taurus. But around 10,500 BCE, it was Leo, a lion monument aligned with the rising constellation of the lion. Coincidence? Possibly, but when patterns repeat, coincidence becomes harder to dismiss. Now let's step away from stone. Let's talk about stories. Nearly every culture on Earth tells a story about a great flood. Not a future one, a past one. A time when the waters rose and destroyed the world. In Mesopotamia, Utnapishtim survives the deluge in a great boat. In the Hebrew tradition, Noah does the same. In India, Manu is warned by a god and preserves life through a flood. In Greece, Deucalion and Pyrrha survive Zeus's destruction. In China, Yu the Great controls devastating waters. Indigenous cultures across the Americas, Australia, and the Pacific recount catastrophic floods that reshaped the land. Over 500 flood myths have been documented worldwide. Of course, floods are common human experiences. Civilizations cluster near rivers and coasts. Local disasters become mythologized over generations. That is the conventional explanation. But consider the scale of sea level rise at the end of the last ice age. Between roughly 15,000 and 7,000 years ago, global sea levels rose by over 120 meters. That is nearly 400 feet. Continental shelves that had been dry land for tens of thousands of years disappeared beneath the ocean. The Bering Land Bridge between Asia and North America vanished. The land connection between Britain and mainland Europe drowned. Vast regions in Southeast Asia became islands. Coastal plains around the world were swallowed. And while much of that rise was gradual on a geological scale, it was punctuated by sudden meltwater pulses, episodes where sea level may have risen meters within a human lifetime. For coastal populations, this would have been catastrophic. Imagine your village, your ancestors' graves, your hunting grounds, slowly overtaken by the sea. Then one year, a storm comes. The water does not retreat. The land is gone. Within generations, all that remains is a story about a world that drowned. Now combine this with a hypothetical. If a complex maritime culture existed along Ice Age coastlines, one that developed navigation, astronomy, or organized society, where would its remains be today? Underwater, beneath 100 meters of ocean, covered by sediment. Marine archaeology has explored only a tiny fraction of submerged continental shelves. The majority of the Ice Age world remains unexamined. We assume nothing advanced existed there because we have not found it, but we have barely looked. This brings us back to the eraser. Imagine again that humanity vanishes tomorrow. Within centuries, cities crumble. Within millennia, they are buried. Within millions of years, plate tectonics recycle crust. The ocean floor renews itself every 200 million years. Anything older is gone. Even on continental crust, erosion and metamorphism alter the surface relentlessly. After 10 million years, our physical structures would be nearly impossible to detect. After 50 million years, almost nothing recognizable would remain. Only subtle chemical anomalies, which might be interpreted as volcanic events, or orbital cycles, or methane releases. We are not nearly as permanent as we think. So, what are we left with? Let's review without drama. We know the Earth is ancient. We know climate can shift abruptly. We know cosmic impacts occur. We know sea levels can rise catastrophically. We know the archaeological record is incomplete. We know Göbekli Tepe predates agriculture. We know the Sphinx debate remains open. We know flood myths are universal. None of these prove a lost civilization. Individually, each anomaly has a reasonable explanation. Collectively, they form a pattern that whispers. Now here is the important part. The most parsimonious explanation is that we are the first technological civilization on Earth. There is no smoking gun, no buried city of advanced machines, no fossilized microchips. But the absence of evidence is only meaningful when evidence could survive. And on a planet that melts and recycles its crust, survival of evidence is rare. The Silurian Hypothesis does not insist that we are the second attempt. It reminds us that we cannot confidently rule it out, and that humility matters. Because there is a second layer to this question, one that points forward, not backward. We are altering the planet at geological scale. Carbon levels are rising at a rate that rivals ancient climate events. Oceans are acidifying, species are disappearing. While future geologists, millions of years from now, may drill into rock layers and find a thin band, a sharp carbon isotope excursion, microplastics, artificial radionuclides. They may debate what caused it. Volcanism, methane, or something else? And if they are intelligent enough, they may ask the same question we are asking tonight. Was there a civilization here before us? And if there was, what happened to it? Maybe we are the first. Maybe we are the second. Or maybe the Earth experiments with complexity again and again across deep time, and we are simply one chapter in a very long book. But whether or not someone came before us, one truth remains. We are temporary. The rock is patient. The ocean will rise and fall long after our names are forgotten. Civilizations do not survive by default. They survive because they adapt, because they learn, because they choose to. So perhaps the real question is not whether we are the second attempt. Perhaps the real question is whether we intend to become a thin, ambiguous line in the geological record. Or something more. The past may be an open dig, but the future is unwritten. And for the first time in Earth's 4.5 billion year history, one species understands that. The question is, what will we do with that knowledge?